All right, this video is about geometric optics for a concave mirror. So I'm going to go ahead and start by drawing a principal axis. And for this principal axis, I'm going to go ahead and build it like a number line. So I'm going to go ahead and just label this as my 0 centimeter position. And therefore, everything on this side will be negative position, everything on this side will be positive position, unless some other things happen. We'll see that in a bit. I'm going to go ahead and start by drawing in a curve here, and this will be my concave mirror. So let's go ahead from here to here, and if I wanted to, I could draw the rest of this circle. That's fine, but we'll just go ahead and go from here to here, and then mark that the back side of this is the non-reflective side. So for mirrors, we want to keep our reflective side on the positive, or pointing towards the positive, because our object is going to be in the negative position. So I'll go ahead and set up a radius of curvature here, and it's about there, but just to get a little bit more precise, I'm going to go ahead and take a measurement here, and it looks like it's going to be right around 8. So I'm going to go ahead and use 8 just because that's going to be a simpler number to use. There's my radius of curvature C, okay, and then I'll go ahead and write in 4, which is half. And what's special about this is this radius of curvature, the position of this is at -8 centimeters, is at -8 centimeters. And we have this other point here, which is very special, and it's called the focus, and it is at 4 centimeters. And I'll show you why we label that as 4. If we go ahead and take a light ray that is parallel to the principal axis, and it strikes the mirror, what we have here is, and I'm going to use my 0 here, what we end up having is a reflection of the light through the focus. I'm going to use a dotted line to show that is the reflected light. And I can do that for other parallel lines. Obviously, there's an infinite number of parallel lines that are instant on this mirror. And I can go ahead and show that also. Let's go here, dotted line again. This dotted line, if I follow the path of this light ray, it has come into the mirror and reflected towards the 4 centimeter or focal point. And what we tend to say is the reflected is positive, as if it went in this direction. So what we find here is the relationship between center of curvature, or radius of curvature, sorry, and the focus, that the focus is half of the radius of curvature, but negative. So that's an important piece to remember, okay? So I want to see how this works in application. We're going to go ahead and draw the same setup, the same setup. We have our principal axis, we have our 0 position, we'll go ahead and have our mirror here, okay, non-reflective side. We'll go ahead and draw in our radius of curvature at 8 and our focus at 4, noting that the center of curvature is at -8 centimeters and the focus is at 4 centimeters. So now we're going to go ahead and draw an object, and we'll start with an object outside of the radius of curvature. So we'll go ahead and start out here. So I'm going to go ahead and draw this. Let's go ahead and draw it 3 centimeters tall. Okay, so I'll state that one more time. And this position of that object is at -11.5 centimeters. -11.5 centimeters. So I'm going to write that over here. DO equals -11.5 centimeters. The height of the object, which I measured earlier, is 2 centimeters tall. I may have said 3. Let me measure that one more time. 2 centimeters tall. Okay? So that's important information to have, just to state for later. So let's go ahead and draw some light rays. And remember, if we have a light ray that is parallel to the surface, it reflects through the focal. I'm going to do the dotted line again. This is a reflected. Okay. I can draw another one using that same concept. I can go ahead and go through the focus, and reflect parallel. And I kind of start to see a convergence of light here, right about there. We'll go ahead and do one more. And the one more, that's good to do, and there's a couple more, but I like to do through the radius of curvature. I go through the radius of curvature, and it reflects back, so that's dotted line, along the same path. And what do you get here? A convergence here. So my object is on the principal axis. It'll continue to sit on the principal axis, and it will be upside down. I can go ahead and measure now maybe the position of that object, which looks like it's at 6 centimeters. So the image is at positive 6 centimeters. It is formed by these dotted lines that are reflected on the negative side, but we call it positive. And the height of the image is, it looks like it's about 1 centimeter, okay? So what we can do with this is double check our relationship. 1 over di equals 1 over do. So we can know where the image forms if we know where the object is and we know the focal length. So let's check this. We know this is going to be 6, but let's go ahead and pretend we don't know that. And so I get negative 11.5 plus 1 over 4. When I do the math here, if I go ahead and do 1 divided by negative 11.5 plus a quarter, I end up with a number like 0.16 something. And if I take the inverse of that, I end up with di equals 6.1 centimeters. Pretty close to that also. So this is one thing that we can talk about. If I end up with an image on the reflected side, it is going to be a real image, and I can produce that on a screen. It is inverted. It is an inverted image and smaller. Okay, so, and I failed to do this. So the height image is negative 1 centimeter. So check that, negative 1 centimeter. We can also look at the heights of these and recognize there's a magnification. And magnification is found by the image height over the object height. And in this case, we get negative 1 over 2. So my magnification is negative half, which tells me that it is negative, it is upside down, and it is smaller by 1/2. Okay, so we already did an example with a concave mirror that is where the object is outside of the radius of curvature. I'm rebuilding the same setup as before, where I have my mirror, I have my reflected side, and then I want to go ahead and set up my radius of curvature and my focal length, or my focus. There we go. So this is my curvature, this is my focus, remembering that our radius of curvature was at negative 8 centimeters and our focus is at positive 4 centimeters. So I'll go ahead and draw another object in, and this time I'm going to go in between the radius of curvature and the focal length. So let's go ahead and choose 6 centimeters, and I'll go ahead and draw this 2 centimeters tall again. Okay, so 2 centimeters tall. Write that down so I don't forget that the object position is at negative 6 centimeters and the height of the object is positive 2 centimeters. So we'll go through our process once again, where we have a light ray from the tip coming in parallel, therefore it reflects through the focus. We'll do that dotted line. Okay, we'll go ahead and go through the focus and then reflect out parallel. And then our final one through the center of curvature. It looks like I did not do a very good job at doing parallel here. I might be a little bit lower. That is my fault for not being as precise as I should be, because I'm recognizing I'm going to rotate this. I'm recognizing that when I do go through the center of curvature, that I'm going to end up with light ray coming in, and it actually back this way. And it looks like my image is going to be right in here. The tip of that image is going to be right here. It's still going to be inverted, but it's going to be larger. And maybe I'll use this right here, because it looks like I have a good amount right there. So let's go ahead and draw that in there, and let's see how close the mathematics get to this. So let's go ahead and write that down. It looks like I'm going to expect to get right around 11. The image is going to be right around positive 11.3 maybe centimeters. Let's check that out. So we'll go ahead and do the math one more time. Again, 1 over di equals 1 over do plus 1 over f. So let's check. My object is at negative 6. My focus is still at 4. So if I go ahead and check those numbers, I'll end up with image position of 12 centimeters. So I'm a little off by about, well, 7/10 of a centimeter. Okay? So these numbers are A-okay. So that image, so if we wanted to describe this image, it is larger. I could go through the magnification again. Magnification is the HI over HO. So my magnification is, go ahead and measure that up. Looks like it's about 4. Is 4 centimeters over 2 centimeters. And I failed to put in that as a -4. So my magnification is -2, which means that the size of the image is twice as big, 2, but upside down, negative. All right, our last region to talk about is when you are within the focus. When the position of your object is now on the other side of the focus, between 0 and 4. So rebuilding one more time. Non-reflective side. Go ahead and get my radius of curvature in at -8, focus at +4. Again, write that down. Okay, C and F. I'll go ahead and draw in an object, and let's go ahead and do 2 centimeters. And we'll go ahead and draw this 2 centimeters tall again. And I'll write that down. So my object is at -2 centimeters. That is the position, because this is 0. Negatives are on the left side. And the height of the object is also 2 centimeters tall. And now the rules still apply. The same rules still apply. I'm going to have a array that is parallel to the principal axis reflect through the focus. Okay? And I'll go ahead and a line that is, or array that is extended through the focus. So I'll go ahead and array through the focus. So from here, and I will go out. Let me go and extend that a little bit further to the 0. And I'll go out. And I can already see when I do this that we have diverging reflected rays. But let's get one more in there, and that is through the center of curvature. Extending through the center of curvature, and I back the reflection, and still they're all diverging. There's an angle here. These aren't parallel. There's an angle here. These aren't parallel. So in this case, what happens is our eyes are going to focus on those diverging, and I'll go ahead and continue in a solid line. Let's go ahead and get that. Sorry, a dotted line, my fault. Something like this. I'll go ahead and continue in dotted line. And the dotted line is going to remind me that this is a path, and I want to make sure I flip my signs here. It looks like I get a convergence right about there. And I end up with an image there. Okay. So I have this image now produced. I'm going to go ahead and measure that out, and it looks like it's right about 4 centimeters. So I'll write that down, that my image formation is at 4 centimeters. I really want to think about what this means, because I have these reflected rays, and I recognize that those reflected, even though I might have an image produced on the negative side, we call it positive, but now I have an image produced on this side by reflected rays. So this is going to be a negative image distance. The height of that image, let's go and get the measurement there, is, it looks like it's about maybe 4.5, maybe 4. I'll write 4.5, but it's positive 4.5 centimeters. So I'll go through the process again. 1 over di equals 1 over do plus 1 over f. So my image, let's go ahead and pretend we don't know it's -4, but I do know -2 plus 1 over f, which is 4. And you might be able to do this math quickly here, but I do end up with an image position of -4 centimeters using that. And then my magnification is positive 4.5 over 2. So my magnification is going to be just over 2. We're going to 2.25 it. So I can write that down. That is positive 2.25. Approximately. I'll go into this at a later date of how to find magnification based upon positions and such. But this is telling me that the image is virtual with that negative sign. It is on this side of the mirror. It cannot be produced on a screen. But this positive magnification tells me that it is upright and it is larger than 1, the magnification, so therefore it is a larger image than the object.
Go ahead and subscribe, that'd be great. Or you can go ahead and check out my next video. Take care.